Okay, this is the last part in our first series on using variables and basic input-output and some basic control and flow to solve 8th grade mathematical problems. And the last one we're going to look at today is Pythagorean's theorem. So if you haven't done our first two greetings and the slope one, I invite you to look at those. Part 1, 2, and 3. This will be part 4, Pythagorean's theorem. So I'm going to create a new, and I'm going to name it this, PYTTHM, PYTTHM, short for Pythagorean's theorem, of course. And the first 3 lines is normal. I like to clear the home page just to make sure that I'm working clean. Then I like to put my name on the program. And in this case, by TMP, and I forgot these. To insert something, you could press second insert and the block will go to an underline. And here I have by the math prophet, and because I really want you to see that for a while, I'm going to pause the screen. But sometimes, if I'm programming for somebody else, they're not going to know what to do. So I'm going to tell them that if they want to go on, they have to press enter. Alright, so that's the first 3 lines I make in all of my calculator programs. Then, for the Pythagorean theorem, there's 2 cases. There's one where you have the 2 legs and you're looking to find the hypotenuse, and the other where you have a hypotenuse and a leg and you're looking for the other leg. So we're going to create a menu to figure out which case they have to do. That will help us write only one program instead of writing 2 programs. So program, I'm going to go around the bottom because I think it's like C. There it is, C. And remember, we have our title will be which case, and I'm going to throw a question mark in there. So that's the title of the menu. Then I have the option A, which will be find the hypotenuse, and that will be option A. And the second option will be find the leg. Alright. Again, after menu, but before the first label, a great spot for a little Easter egg there. So I'm going to put a label in. I believe that's number 9. My first label is A. Now, under label A, it's going to be find the hypotenuse. So if I'm going to find the hypotenuse, I need to ask for both legs. So I'm going to do program, input. I'm going to ask for leg 1. And then remember, when I use input, I need to store it. This is a numeric variable, so I'm going to store it in a letter. I'm going to choose N. It doesn't matter. I'm just going to choose N. I don't like how TI Basic, when you fill the whole line, it puts that in there. But that's the programming language we're using here. So input leg 1. If you think you know what the next line is, go ahead and put it in. Otherwise, I'll do it now. We're going to ask for input leg 2. And I'm not a big fan of using O as a variable. It looks too much like 0, so I'll use P. Not 8. I said P. Alright. Now, I have to do some math with that. Pythagorean theorem tells me that I need to square both of those and take the square root. I need to square them, add them, then take the square root. So I'm going to do n, that happens from time to time. I'm just going to go back to editing my program, arrow down to the bottom. So I'm going to do n squared plus p squared, and I'm going to store that in q, and I need to take the square root of q, and I'm going to store that in r. So now r is our answer. We have our answer, and we want to say something like your answer is, and then display r. But we have to do that for both cases. So this is where I'm going to use the goTo command. So I bet that's 0 since label is. So I'm going to go to goTo, and I'm going to go to C. Now I know what you're thinking. Tom, there is no C. That's right. After label A, we have a label B. I want to jump over label B and jump to label C so that I can only write the answer output one time. In computer programming, you want to limit the number of times you repeat yourself. When you repeat yourself, you just introduce error, and we don't want that. So we stored it in R, and then we're going to jump over label B. So now let's do label B. I need to put in a label B. And label B was find a leg. So now I'm going to ask them for an input, but in this case, I'm going to ask them for the hypotenuse. H, Y, P. And I'm going to store that in the same variable I stored leg 1 in before. And I can do that because if this block of code is running, this one did not run, and vice versa. If this block of code is running, the goTo C will make it skip over label B. So the hypotenuse is n. I'm going to have it input Now I don't need to write leg 1 or leg 2 because there's only one leg that I have to worry about because I don't know the other one, comma, and I'm going to store it in P, again because I don't like O. Now, you know, hopefully, that in order to find a leg, you have to square the hypotenuse and subtract the square of the other leg. And I'm going to store that in Q, and then the square root of Q store that in R. Now, if you're a savvy thinker about don't repeating yourself, you'll know that this line here, the square root of Q go to R, isn't actually necessary in the loops. If I sent it to go to C, then I could instead of skipping this with q as the answer, I could use the square root of q as r in both cases, in label C, but I wanted it there because I want to sort of output the answer. That's just a pedagogical thing. Alright, so now, for the sake of practice, I'm going to put in a go to C here, but for practical purposes, I don't really need a go to C because they're... Oh, no, I would need a go to C. I strike that. So, I'm going to put in a label here, C. And now my answer is in R. So I'm going to output. Output again is in display. Display. And then missing side. Missing side. And I want to use the equal sign. Remember, equals under test. Equals close quotation, and remember our answer is stored in R. And finding there. Alright, so now let's run it and see how it works. So program, I want Pythagorean's theorem. It's by me. I'm going to find the hypotenuse first. I'm going to look at the famous 3, 4, 5. The missing side is 5. Wonderful. Now I know that the finding the hypotenuse works. I'm going to find the leg. That's number 2. Let's say the hypotenuse is 13 and the leg is 12. The missing side is 5. So I've just successfully programmed Pythagorean's theorem into the graphing calculator. Thank you, and look for my next lessons on coming soon. Thank you, and have a nice day.